everyone, thank you very much for joining again. We are going to discuss the last part of the Spring context from Spring Start here. We are very close to finish with this very important, essential part of Spring, and if you have followed all the episodes till this one, well, you are almost there, because we still have to discuss AOP chapter 6. We'll go through that one in the next probably couple of episodes, 1 or 2. I don't know exactly how much time we'll need for that, but with this we are almost ready to close all the basics, which is very relevant and very important to any Spring developer. If you are here with me live, you can ask your questions as always in the live chat. If not, you can leave me comments. You can follow me on Discord, on the Discord server, but also on LinkedIn and Blue Sky. And with that being said, I'm going to share my screen because I think it's more important for you to see the book we discuss rather than talk too much about other things. So if you remember, last time we discussed about bin scopes, and we've started with singleton, which is I'm pretty sure the most important. Now, why? Because it's the default one. We've talked about how it's created. We discussed also about eager and lazy initializations. We talked about the fact that it's better to keep immutability on this kind of bins. Never try changing attributes, because we have seen whenever you refer from the context to any singleton, it's called a singleton for a reason. You will get the same reference, and that is, if you try to somehow change things on the attributes, you will get from different threads, you will potentially get into race conditions. Synchronization is also not really recommended in this kind of cases. You will very rarely see something like that. In Jakarta EE, actually it was Java EE back then, this was even specified in the specifications, but normally it's almost impossible to see that in practice. So my recommendation is you just keep your singletons immutable, okay? And whenever you need to have multiple instances that you create for the same type, then you have this prototype bin scope. Now I'm gonna be very honest with you. The prototype bin scope is something that you also rarely see in a real world application, because in most of the cases, when we have this kind of situations where we create instances of some prototype, is usually to represent some data, to model some data. So we create those objects with classes that are part of the model. And in the majority of the cases, you don't need Spring to interfere with the model classes. It's very, very, very rarely that you see Spring interfering with model classes. And I will tell you, so the only situations up to now in my many years of experience already with Spring where I needed the prototype scope were more to like cover up some design flows for a period of time until I was able to redesign some old application. So I had in some cases where, you know, this kind of I don't even know how to call them. It's like, imagine some manager classes, classes that somehow contain parts of the use cases. They were mutable, first of all, so that was one of the difficulties, and we just discussed the fact that singletons are not really friends with mutability. They should be immutable. And secondly, they were basically they were created, so the services implementing the use cases were creating instances of these classes and then use them for only that short period of time of executing the use case. Very strange normally to see something like this in a real world application, because there is no reason to really create one instance and then throw it away. The only thing in this case, because the only thing you manage to do in this case is to put some pressure on the garbage collector, because you will just give your garbage collector a little bit more work to do, but otherwise it's unnatural. So normally we go through that immutability part when we design part of the execution, and because the model classes in most of the cases, almost all probably, don't require intervention from the Spring framework, it's very unlikely also to see the prototype bin scope. But if you are in a situation like me where you will have to redesign some bad application, and majority of the developers with experience know that redesigning of a big bad designed wrongly designed application is not possible to be done like that. You have to like spend some time to do it, and you can't really just work on it and leave the scratch there while you are working. You need sometimes to do workarounds, and who knows, in many cases where you deal with old code, you might need here and there some workaround where you need to use a prototype bin. So that's why we discussed this today, and I think it's important developers to know that this tool exists. I won't spend too much time on it, but it's important, this exists. So can you please make a playlist of Spring Security 6? I think the existing playlist actually covers Spring Security 6, although I know there are some small things that don't work. If you start from the beginning, you will see it starting with 5, but then it continues with 6, and I think the majority of the important things are covered already in the existing framework. So please check it. You will see that I'm probably right with that. If not, we will discuss it on Discord. The sound is quite good, but usually it's better. I didn't change anything in the sound. Maybe it's the connection here. I don't know exactly, but I will check it afterwards. So I hope you can still hear me. If not, I'm not sure. I'm live now, so I'm not sure how many things I really can do. So I hope you still hear me pretty well. Good. Let's go a little bit through the book. Now we are going through this, and I was already explaining you what a prototype bin is. So a prototype bin is when you can think it like that, and I always like to make analogies, and in this case the analogy would be, think about if in the case of a singleton we represented the instance as a coffee bean. No? Because you already have the coffee bean created by the context itself. It either happens eagerly when the application starts, or it happens when it's requested, if it's marked as lazy initialization, but it's always the bean there. So the coffee bean itself, it's identified by an ID, and you can take it from the context. No? Now imagine when we talk about prototype that you don't have a bean in the context directly, but you have the coffee plant. So the coffee plant creates beans for you, but you will always get a different bean. It's not one bean there that you have identified and you always refer to it, as it was in the case of the singletons. It's a coffee plant that you have identified, so whenever you request a bean, you will get a new bean from the coffee plant. So you get the difference. This is how it looks like. Now, if you remember what we have discussed, you know that whenever we have used getBean on any kind of bean identified in a way in the context, and if that was a singleton, so you see here specifically this is marked as a prototype. if I haven't used the scope annotation, by default it would have been singleton. So if it would have been singleton, because I haven't used the scope annotation, which was what we discussed in the previous lesson, then whenever I would have requested with get bean the identifier, I would have really got the reference to the bean, the coffee bean, in the context, which means that always here I would have had the same address. So then the result of this operation would have always been true. But since here we have annotated the creation of the bean with the scope annotation specifying that we want this to be a prototype bean, instead of having the beans, we have the plant. So whenever we call the plant, we always get a different bean. So in this case, this operation will always yield false, because there will always be different references to different instances, because you get the bean from the plant and not the bean that has been created directly and it's unique in the context. The scope annotation can be used wherever you create a bean with an annotation, which means either, as you can see it here, on a method in a configuration class annotated with that bean, which we know from chapter 2 that this is one of the possible ways to create beans, or using a stereotype annotation such as component, service, repository, controller, or the composed REST controller, about which we'll discuss in the second part of the book. Very good question in the chat. So do we have race condition in the prototype bean? It's unlikely to have a race condition in the prototype bean, because that would mean that somehow we have to store this on an attribute and have the threads acting in a singleton, and have the threads acting on that, which is something that we never do, because we always get a different bean. It's unlikely that you will have, unless you have on purpose created a design which would allow that to happen, which probably would never happen. No, this cannot happen, because you will always refer to a different bean. So if you change something, now you know that that bean you get here, you can change throughout the local context of this method, and so therefore there is no other thread that can interfere with the exact same bean. So if you have two threads and they both request a bean, they both request a bean from the plant. Now you might ask yourself, and can the request of the bean from the plant, so therefore the creation of the beans, create some kind of a race condition? The answer is no, because it will be taken care by Spring. So normally it could, if you would design your own context, you would have to take care of this, but since we are using the Spring context, which is pretty smart, it already incorporates the synchronizations and everything you need in terms of creating the beans. So you don't have to worry about that at all. You just get the bean, and Spring will make sure that the creation of the bean is synchronized, and you will not run into any kind of a race condition when your plant creates the bean. So that's why in this case, we use the prototype beans in such designs where we cannot use immutability, for example, and we cannot use in that case a singleton, because that would require synchronization. So at configuration for Kafka, let's say if you want to override the properties of it, will it load this kind of container of beans? I'm not sure if I understand the question, to be honest. So you have a configuration class and you define the beans. You define the beans whatever you want them to define the beans. So if you want to define them as prototype, you define them as prototype. If you don't use the scope, they will be default singleton. Again, I don't see the relationship here between Kafka configuration and beans. Maybe if you can be a little bit more specific, Adrian, I can try to figure out how to answer that question. Okay, and this is the explanation. Actually, it's exactly the explanation to the question. No, can we get a race condition? No, because you have thread 1. This is the arrow representing the time arrow for thread 1. This is thread 2, so it's representing the time arrow of thread 2. They both request the same bean, but they get two different beans because the plant here will give a different bean every time it's requested. Therefore, thread 1 and thread 2 will always use a different bean, meaning that if they change something, only them can change on their own bean. The creation of the bean is synchronized at the context level, so you don't have to worry about that. Okay, and then you can see here, I guess, an example. Okay, maybe we can just go on IntelliJ ourselves and try to see it exactly, and then go back to the book. So this is exactly what the book shows you next. So you have this class. No, it's just a simple class, you don't have to mind about it. I'm creating an instance of the class, in this case using the bean annotation, so exactly as you have seen also in the book example. And what's different here is that I augment my definition with the scope annotation, specifying that I want this to change to prototype scope. So bean definition is a very it's an interface, and it declares itself the two possible scopes, so that you don't have to put them as a string because it's ugly as a string. Remember, putting anything as a value here, like you can do that. Maybe you will see that somewhere. No, it's like do that prototype. No, prototype. No, and this works. Okay, technically it's correct, but from a maintainability point of view it isn't, because this is what you call a magic value here. Usually we avoid doing something like that. We prefer, and especially where we have situations where we repeat or potentially might repeat the same thing, to use the declaration of a constant. So in this case, Spring already provides you the bean definition type that comes with this constant scope prototype. It comes also with the scope singleton, but naturally you don't have to use that, because, well, you can use scope singleton definitely, but it's the same as basically not putting the annotation at all. So normally, if you want your bean to be singleton, you just do as we did in the previous lesson, in the previous talk, and you don't use the scope annotation. It doesn't really make sense to put the scope annotation just to somehow enforce the fact that the bean is a singleton. It's just, again, boilerplate code. No, you don't want to see it there. So if I'm running now this, I will get a false no, because this one being a prototype, I'm not getting the bean directly from the context, but I'm getting the bean from the plant in the context, which means that CS1 and CS2 will always be two different references to two different instances in the memory, and that's why, as you can see, the result here printed on line 17 is false. So I hope that makes sense. And with that we can go a little bit further, and yeah, in the book I gave a lot of examples, so you can go through all of them. I don't think now it's necessary to go through all of them in the code, but my recommendation is, and especially if you are not reading this book only as a refresher, but you are reading it to study it, you should take all the examples and run it one by one. But in this case, for example, I just proved that you do the same thing. You can do the same thing using stereotype annotations, because again, the scope annotation that we use to define the scope of the bean can be used wherever you create a bean. So that is, if you create a bean, for example, with annotations, you can use it either on the method in the configuration class with add bean, or on the class with the stereotype annotation, in case you use stereotype annotations like you see in this example here. if you would use the register bin method, you have a parameter on the register bin. That's the programmatic approach. We very rarely use that, but if you would have to, you still can create your bins as prototype. You can register your bins in the context as prototype, and you have a parameter for that. And for the old guys who saw also declarations as XML files, there is a tag that you can use to specify the scope in the XML file, but let's skip over that discussion because it's been many years since we don't use that anymore. And unless you really are working in a very old application where I don't know, you really have to use XML because there is no other choice, today you won't ever see something like this. So you can see here that I'm auto wiring this, and there is a thing that I want now to make you attentive in some cases, in some things. But before I'm making you attentive, remember please that we have discussed in the wiring bins chapter, in chapter 3 here, that in real world scenarios you should always use constructor injection. Now you remember that we discussed about auto-wired, which you can use on the field, on the constructor, and on the setter. And from all these three, the best choice is constructor injection. So throughout the book here and then, I'm still using the field injection. You might wonder why I'm using the field injection, because you say, hey, if this is not recommended, why the hell are you using the field injection in this case? It's because in the book I need to be short, and usually declaring it like that was shorter, so it's for sparing pages, paper pages, because the book was also printed on paper, okay? But normally in real world examples, please always use constructor injection, okay? So don't take this example, take the examples that we discussed in chapter 3 for that. Okay, so you can see how it works. You can see that we have the same thing here, and you can run it. Okay, so this is basically, is it chapter example 6? Okay, let me see if I can actually find that 6. Okay, this should be the one. Greetings, hello as well. I'm very happy that so many people from all around the world are here with us. And please continue to ask your questions if or start the discussions if you want. And of course, remember that you can also find us and follow us on Discord, where I created a little bit more interactive way of discussing. So what do we have here? Now let me make sure that I'm in the right place. So I'm here, see, it's underlining, it says don't use this, field injection is not recommended. That's what I was telling you. Okay, same here, and this is defined as prototype. Normally you will never have a repository prototype, so this is just for the sake of the example here, okay? So just for the sake of the example. So I'm gonna get, you see, I have two different service classes. Now user service and comment service, they both auto-wire the same repository. Clear? See? If this repository was a singleton, as we discussed in the previous discussion, in the previous lesson, then that result would have been true because both of them would refer to the same. But since we have a prototype, then it's a false. You can easily distinguish. You know, if you comment this out and run it again, assuming that IntelliJ is also a rebuilding. Be very careful, sometimes IntelliJ uses caches, so you might see strange results because of that, because maybe it kept in the cache something. It didn't happen to us. You can see the result automatically changed to true just because I have commented this out, because now both classes, both service classes refer to the same instance. If I use this annotation, then you already got what happens. Instead of the bean itself, we have the plant, and whenever the two services will get some instance, they will always get a different instance. So automatically, these two being different instances in the memory, they have two different references, and then the equal sign, whenever we use the equality operator between two objects, we know that it compares the references, and that proves that we have two different instances here. This result will be false always in this case. Great, going back, no? So we have seen this, and let me see what's the next one. So we get a different instance. Well, yes, we have seen that. Great. And now let's see different things. So it's whenever you have, say, a real world scenario, this is tries to make it a simple version of that scenario that I was telling you, where you have some kind of a manager class, just that in this case I named it a processor. And what you can see here is that this has a non-final field. So you see that this is basically not immutable. So this object instance, even the comments here, see, try to enforce the fact that the methods of the object might change the value of the attribute. So now imagine you are working on an old application, and your task is to put it in Spring. So you will have to work on this design and recreate it, and you have objects like this. Dark mode, no, sorry, I'm never using dark mode with presentations, and I have my reason for that. Anyway, if I put it to dark mode, there will be others asking for the light mode, so I'm sorry, but this is that kind of debatable thing where some prefer a way and some another. So please allow me keep it the way I know is best for me. Okay, so what do we do in such a case? Of course, the best would be to try to refactor this to immutability, no? Which sometimes is possible, but sometimes it isn't, depending on how much work you have. So let's see that you find it's impossible, but you find that you could still continue using it and use it with Spring if you make this one a prototype. So in that case, you can basically transform this into a prototype and use it. Now, you of course would ask again, you should ask yourself, is this really needed to be a bean? Because remember what we have discussed in all probably of the previous lessons. Not all the objects need to be beans. So when do you need an object to be a bean? When you need Spring to augment it with something. So you have an aspect, or you have any kind of annotation like AutoWire, transactional, and so much and so forth. And with that being said, yeah. In that case, if you have this, you really have to make it a bean, no? Because Spring only knows beans. So in this case, this is, let's say, the savior solution. You make that a prototype, and then you can use it as a prototype for the time being until you have the time to redesign it. So you have the example here. You can see the example here. And of course, a distinction here between the singleton and the prototype. So remember, when you have the singleton, when you have the singleton, you have not necessarily only one instance of that type in the context, but whenever you have an instance, it is identified by an ID, and when you call the ID, you will always get that same instance ever again. When you have a prototype, then it's like, imagine you have the plant in the context, and you can request the bean, and then the plant will always give you a different instance. So whenever you use a singleton, immutability is, from my point of view, required. You should always use immutability. If you have something, some bean that is not immutable, and you cannot make it immutable for the reason of the logic, then you need to make it a prototype. However, before making anything a bean, regardless if it's a singleton or a prototype, also remember that it's best for any object to not be a bean. So you prefer to avoid an object being a bean. Okay? Why? Because being a bean can be controlled by Spring. That's when you make an object a bean. And being controlled, it means Spring will add that overhead over the bean. So to make your app performant, the least number of beans you have, the better for your application. So making something a bean is not I make a bean, an object a bean, because it's cool, fancy, or I need all my objects to be beans. It's the opposite. Preferably my objects should not be beans. I create them as beans only and only if I really need Spring to augment that object with some capability. That's very important. And I think we are finally at the end of this chapter, and I knew that this lesson will be a little bit shorter. I'm not going into chapter 6. I'm going to go into chapter 6 next time, because I want to have it like an united, let's say, discussion on chapter 6. I don't want to split the discussion and start another chapter now, but I want to see your questions, and also I want to now, because we are at the end of this 2, 3, 4, 5, now we've discussed, we had 4 chapters only discussing the Spring context. I think it's essential now to go from the very beginning to the last chapter we have discussed, to 5, and remember the important things that you need to know, and that you need to know for working with Spring, but also, for example, if you attend a technical interview, you might be asked about the Spring context and how it works, and things like how you create the beans, how you auto-wire the beans, using abstractions, and the bean scope and life cycle. These are very important. Now, so let's recap a bit. First of all, try to make a difference between creating beans and obtaining beans. I saw many developers, especially beginners with Spring, not understanding properly the auto-wired annotation. You cannot imagine how many times it happened to me to ask, for example, candidates in an interview, what does the auto-wired annotation do? And then the answer was, it creates a bean. False. The auto-wired annotation doesn't create the bean. The auto-wired annotation is used to get the reference of a bean that already exists in the context. Of course, there is the situation where the bean that you requested is defined as lazy, so it will be created at the first interaction, but that doesn't mean that auto-wired creates the bean even in that case. So a first important thing to remember is to make the difference between declaring objects as beans, so the part that relates to what creates and how the beans are created by the context, which is using the bean annotation over a method in the configuration class, using a stereotype annotation, using the registered bean method programmatically, or in the very old-fashioned ways using XML files. This is related to creating the beans. This is when the developer marks somehow an object as a bean, and then auto-wired is when we get a reference to a bean. So first we put the beans in the context, declaring the objects that we want Spring to be able to manage, and then we use auto-wired to create references between the beans that have been created from the ones declared. Okay, some more comments in the chat. The Discord channel, you can find it in one of my comments. I will try to make it more visible as well. Thank you very much. You can find it in the community in one of my comments now, just to be quicker. A playlist, a complete backend project. That's not a bad idea. So I'm thinking about doing that. Of course, I will only focus probably on the application side, because there are also parts such as deploying the application, which could be a little bit more challenging to describe in a video, but we can discuss about the backend project as well. Stumbled AutoWire integration tests, I guess it's ITs, no integration tests, how to construct an injection does not work similarly to normal components. We will get into testing somewhere in chapter 15, so I know it's late. I know you have to wait a bit till that, but I especially let this at the end because we need first to discuss all the things that you can do within an application before trying to test them. So I will discuss that, and hopefully at that point I will clarify that for you. So what will happen when a bean depends on another bean? When you create, I guess when you create in the context, what happens? So that's a very good question actually. So if, for example, if you have this bean A and it depends on bean B and bean B doesn't exist yet, this creates the so-called graph of dependencies, no? And yes, exactly what you say. So then Spring will know and will create the dependency before. And that's basically the reason why sometimes you might get into cyclic dependencies. Remember, we discussed about cyclic or circular dependencies at some point. It's because if you use the constructor injection, what will happen is that at some point, if you have created, if you wrongly create the design where a bean depends on another and the other on the first, then Spring will try to create this one, and then we'll go into creating the second one, and then we'll realize that it needs to create the first one again, and then it will mark this as a circular dependency and will throw an exception. So yes, Spring is smart enough, you don't even have to care about that. It creates the graph of dependencies itself, and it creates automatically all the dependencies before. The only thing you need to be careful is not to create circular or cyclic dependencies. How do you determine whether you need to create a bean or not? In what situations do people usually create beans? So again, a very good question. Remember that what we discussed, an object has to be a bean only if you augment it with capabilities from Spring. So for example, do you need to use dependency injection? Do you need to use transactionability? Do you need to use any security features on that class? Anything that you need to use and is provided by Spring, if you have anything that you need to use and it's provided by Spring, Spring would not be able to provide that unless you make that object visible to Spring, which means making it a bean. If you have an object, which usually happens to the model classes such as entities and DTOs, no? that don't need to interact with Spring, for which Spring don't have to provide any functionality, any capability, then you don't need to make that a bean. Very often, for example, if you have, for example, Hibernate in your project, now when you create entities, those classes annotated with the entity annotation. In that case, in that particular case, you will very rarely see these classes annotated with made of beans and annotated with Spring annotations, because it usually doesn't make sense. You don't have where to use that. So see, those are never beans in Spring, because Spring doesn't need to interfere with them. If you would need Spring to interfere with them anyhow, you can make them as beans, but it rarely happens. Have you ever implemented with domain-driven development, and if yes, does it affect how many beans one creates? Domain-driven development, it's actually something I use in exactly the current project I'm consulting. So yes, I have been using, and yes, I am using it right now. Just happens to, no, it's not mandatory, but it just happens that I'm now exactly on this kind of a project. The domain-driven development, it's somehow related more to the whole architecture of the system rather than the way an application is created, which means that I don't see any reason you would say DDD would impact the number of beans in an application, because DDD doesn't impact the application. What may impact the application is a design style you choose. For example, you might have a linear design, or you might choose a hexagonal architecture. But mind that hexagonal architecture, even if in many cases I have been seeing it used with system design on DDD, it's not mandatory, okay? Even though that either, I would say, impacts the number of beans. So to answer your question, I don't think any of the DDD approach or hexagonal architecture would impact on how many beans you create in your application / system. I don't see how it has. Yeah, I thought when you wrote DDD, I thought that you mean hexagonal architecture actually, but no, even that. Actually, to be honest with you, hexagonal architecture is in many cases abused, because normally it should be used, from my point of view, when you have some complexities above level. Otherwise, you will end up with having many interfaces, many contracts, no, because you have the slices of the hexagon, and then you have the interfaces, the contracts that allow these parts to communicate with one another. In case you have complex applications where you have potentially even different teams working on each slice, it might make a lot of sense. In case of small applications, so usually I would say microservices, I see a big impact on the maintainability. I don't see any impact on the number of beans and how Spring is used. Spring is used the same way. The only thing is that you will use abstractions a little bit more. So chapter 4 here would be a little bit more relevant for you. But it adds complexities from different point of view, no? But you know what happens is that many enterprises, many organizations, they prefer to use it, like, even if regardless of the application in the system, if they feel that the majority of the application need a hexagonal architecture, they just say, hey, use hexagonal architecture everywhere, just because we want to be to have the same design everywhere, which would help the teams like be switched easier, developers from a team to another and stuff like that. there are many things to discuss here. It's very difficult. It's a very difficult subject, actually. Again, to be on point with your question, I don't think it impacts the number of beams in the context, but it impacts many other things that are that can be discussed, and I think we could take a different other talk and then discuss only about this, because it's a very, very large subject. So could you provide a real example from your experience when we need prototype and singleton if we are speaking about MVC? It's exactly what I was telling you in this video. I'm not sure if you joined later or you have been attentive to what we discussed here. I was telling you about this case. I said, hey, prototype, you don't use it very often, but if you have this kind of case here, and I'm going back to the lesson, okay, to, what was it, the processor, no? So you have this kind of object. No, I've named it a processor here, and I said, hey, the problem is it's not immutable. See, but I still need to augment it with Spring. So I need to make this process comment transaction. What happens in my case here? I have this object is not immutable. Let's assume we cannot make it immutable. Okay, let's assume it's just too much work to make it immutable. But I need to make this method on line 12 transactional. Well, I cannot use a singleton in this case, no? So I would need to make it a prototype and use it adequately. So to answer your question, usually it will be a singleton. That's why it's also a default. But if you have a case of a class where you need to augment with Spring capabilities like transactionability or security or anything else, but you still cannot make it immutable, you need mutability at the same time, then the prototype approach would be the only one I can see as being recommended. Okay, so I hope this clarifies the things. Remember to go through. So this we discussed the defining versus wiring. Now, very important. I've seen these confusions many times. You should be able to differentiate properly between them. The abstractions, now, which we just were commenting a little bit earlier, and it's important because things like, for example, hexagonal architecture or any kind of usage of interfaces when we decouple works with Spring, because Spring allows the usage of contracts, so the usage of abstractions, and then of course the bin scopes and the life cycle, which we just discussed today and in the previous lesson. So all these are very important. You should know them very, very well. You should feel comfortable with this at any hour of the day. Okay, they should be no stranger for you than anything else is. So next time we will go into the AOP, which is the let's say the inversion of control for the methods. I like to call it like that, inversion of controls for the methods. And if we covered everything in part 1, which will happen after chapter 6, you know the entire engine of Spring, you know the entire engine behind the scenes from Spring. So that's very, very important. That's very important to understand. And then we will go to MVC and more practical examples, because some of you, I know, they even told me, hey, I'm tired of talking about parrots, cats and dogs. I need to see some practical examples. And yes, part 2 of the book is for that, but you shouldn't go to part 2 unless you pretty very well understand these first 6 chapters. This is basics that you need to know as a Spring developer. With that conclusion, I want to say again, thank you very much, everyone. I apologize for not being able to make everyone happy and answer all the questions and making my screen dark mode and light mode at the same time. I know I cannot make everyone happy, but I hope again that at least a part of you benefit from my knowledge, and I will try to still continue to be here with you and discuss many other things. Thank you very much for being here. I'm waving goodbye and hope to see you for the next lesson.